Hey, welcome back to Beard Squared. In this video, we're going to be doing a review of coordinate geometry by including parallel and perpendicular lines. So let's get straight on with it. So question 1 says, given that the points A, 7, -3 and B, -5, 3, find the distance between the points. Now, what I want you to do is I want you to find the distance between the points using the formula, the distance formula. So pause the video and work it out for yourself, and then I'll show you the solution. Okay, so what I got was this. I substituted the value of x2, which was -5, and then -5 minus 7. I'm going to square that. Plus, I'm going to do y. y2 is 3, and then that was minus a -3. I'm going to square all of that. Okay, and then I'm going to square root the whole lot. So we've got -5 minus 7, which gives us -12. We're going to square -12, which gives us 144. And then we're going to do 3 minus -3, which is +3. And we're going to square all of that. So that's 6 squared, which is 36. 144 plus 36 is going to give us 200. So the square root of 200 is going to be the distance between A and B. Okay, so this distance here between A and B is going to be the root of 200. You can simplify that, the root of 200. Or you can just simplify the third. We could say 4 times 50, which will give us 2 square root of 50. You could even do 25 times 2, which will give us 5 times 2, 10 root 2. Whoops. 10 root 2. Okay. So the distance between A and B is 10 root 2. Okay. Try to do part B here. It says find the midpoint between A and B. So pause the video and try yourself, and then I'll show you how to do it. Okay, so for part B, we're going to use the midpoint formula. That's going to give us the midpoint between the values. Now, we already know what the values are anyway. That's my x1 and my y1. That's my x2 and my y2. We just need to substitute it into the formula. So let's give this a go. We're going to do -5 or -5 plus 7. And then we're going to do y2, which is 3 plus -3. Okay, divide the whole thing by 2. So -5 plus 7 is 2. And then 3 plus 3 is 0, and we need to divide the whole lot by 2. So we're going to get 2 divided by 2, which is 1, 0 divided by 2, which is just 0. The midpoint of AB is going to be 1, 0. Okay, so let's move on to question 2 then. Suppose M is the midpoint of the line segment CD as shown. Find the coordinates of D. Okay, so remember the midpoint, when we're doing the midpoint, we're trying to, we're going to use the formula x1 plus x2 divided by 2, and then y1 plus y2 divided by 2, and then that's going to give us the coordinate of the midpoint. Okay, so use the information that we already have and then substitute it into that formula and see what you end up getting. Okay, so the first step that I'm going to do is I'm going to label the points. It said CD, so my C is here and my D is here. I know that this is my midpoint, so I can use these points of information. Okay, remember this is my x1, my y1. This would be the coordinate for D would be my x2 and my y2. Okay, I don't have those, but I do have the midpoint coordinates. So let's substitute all of that information into the formula and see what we end up getting. So I get -6 plus, I don't know what this is, divided by 2, and then I get my y1, which is 4, plus my y2, I don't know what that is, divided by 2, and that should equal to -2.5, and then comma 3. Okay, it might just be easier in this instance to make this into an improper fraction, so that will give me -5 over 2, comma 3. That's what I'm looking to get. Okay, so let's see if we can try to figure this out. Okay. Bear in mind that this is my x value and this is my y value, okay? So I'm just going to be focusing on each component. So I'll do the x first, and then I could go ahead and do the y. Okay, so let's do it here then. So I'm going to start off with -6 plus x2 is over 2 must equal to -5 over 2, okay? Now, since I've got the same denominator for both of them, I'm just going to do -6 plus x2 is equal to -5. I'm just trying to find out what x2 is, and then I can do, if I plus 6 here and I plus 6 here, I'll end up getting x2 is equal to 1. Okay, x2 is equal to 1. So now let's find out what y is. So y2, I'm going to have 4 plus y2 over 2 is equal to 3. So what I can do here is multiply the left side by 2 and the right side by 2. That's going to allow me to cancel out the 2 on the left-hand side. That gives me 4 plus y2 is equal to 6. And then here, if I minus 4 and minus 4, I end up getting y2 is equal to 2. Okay, y2 is equal to 2. So to answer the original question, the coordinates of D would be 1, 2. Right, let's move on to question 3. Question 3 says, find the gradient of the line segment joining the points 4, minus 2 and 6, 3. Remember, if we're finding the gradient, we're going to be using the gradient formula. The gradient formula, just to work out the gradient, is equal to y2 minus y1 over x2 minus x1. This is basically the rise over the run. Okay, rise over the run. The difference in the y value, this is the difference in the y values, okay, which is the up and down. And then this symbol, delta, means the difference, okay? So the difference in the x, which is the left and the right. Okay, so I want you to use the gradient formula to find out then the gradient between those 2 points. Try to do A and B and then play the video and I'll show you my result. Okay, so for part A, I would have my coordinates of 4, minus 2 and then 6, 3. I'm going to label my points, okay? It's a very good habit to label your points, x1, y1, and then x2 and y2. And I can substitute those into the formula. So I would get 3 minus negative 2 over 6 minus 4. That will give me 3 plus 2 is 5, and 6 minus 4 is 2. The gradient is 5 over 2. So for part B, I'm going to do exactly the same thing. Remember to label your coordinates. So I'm just going to write these down. Let's label these now. So I've got my x1 and my y1 and my x2 and my y2. I'm going to substitute those into the formula. So I've got 5 minus 7 over negative 2 minus negative 2 again. Okay, so I've got 5 minus 2, which is minus 2. And then I've got negative 2 minus negative 2, which is basically 0. Anything divided by 0 means that I have a gradient which is undefined. Now, what does undefined mean? It basically means you have a vertical line. Okay, the line segment or the equation of the straight line here is going to be vertical. So moving on to question 4, the graph shows the distance traveled by cyclists over time. Find the average speed of the cyclist, A from point 0 to A, B from point A to B, and then C for the whole trip. So I think what we're doing here is we're looking at time and distance. Okay, so we've got speed is equal to distance divided by time. Okay, or DST. What I want you to do is work out the distance between the points using the distance formula. We've covered the distance formula already. So do parts A, B, and C for yourself and then play the video and I'll show you my work solutions. Okay, so for part A, starting from the origin 0, we're going to have the coordinates 0, 0, and A has the points 1.5, 60. Okay, so let's substitute these values into the formula. First thing first, let's label these points x1, y1, and then x2 and y2. So we have distance is equal to my x2, 1.5 minus 0 squared, okay, plus 60 minus 0 squared, the whole thing squared. So it's going to be 1.5 squared, which is 2.25. 60 minus 0 squared, which is 3,600. I need to square root the whole lot. So the square root of 3,600 and 2.25 is about 60.01 kilometers. That's the distance between point OA. Okay, the point OA, the distance between OA is 60 kilometers. What we need to do is find out speed, so we're going to do divided by time. Now, if we look back at the graph, so since time is on the x-axis, if we look at the x-coordinate here, we'll find out what the difference is between the x values, okay? So here the x value was 0, 0, that was 0, and then we're probably going up in half-hour segments, so that's 30 minutes. That there would be 60 minutes, that there would be 90 minutes, which would be an hour and a half. If we carry that pattern on, that means that's 2 hours, that's 2.5, that's 3 hours, that's 3.5, that's 4 hours, and that's 4.5 hours. And we can confirm that's 4.5 hours. So the time, the x value, okay, this is going up in half-hour segments. So we're going to be dividing from 0 to a, we're going to be dividing by 90 minutes or an hour and a half. So we can divide this by 1.5. So 60 divided by 1.5, that gives us a value of 40 kilometers per hour. Okay, that's the speed between OA. Let's do the same thing for part B. Part B starts from the point A, which is 1.5, 60, and then point B has coordinates 4.5, 120. We're going to substitute those values into the formula. So very quickly, let's label them x1, y1, and then x2 and y2. So we get 4.5 minus 1.5 squared plus 120 minus 60 squared, square root the whole thing, we find out the distance. So that's going to be 3 squared plus 60 squared, square root the whole thing. I think 60.07 kilometers. So the same thing applies here. We're going to be dividing by the time. And remember, these are half-an-hour slots, okay? Half-hour segments. So from A, the first half-an-hour slot, and then that's an hour, and that's an hour and a half, that's 2 hours. That's 2.5, that's 3 hours. There's 3 hours between A and B, so we're going to divide this by 3, and we end up getting 20 kilometers per hour. Okay, 20 kilometers per hour. So to work out the speed for part C, we're not going to go from O to A to A to B. We're going to go directly from O to B to work out the average speed of that journey. So we need to know what happens when we go from O to B directly, okay, a direct route. So let's try to work this out. Right, moving on to question 5. Does the coordinate -4, -13 lie in the line with equation y is equal to 2x minus 5? And part B, find C given that 2, 2 lies on the line with equation y is equal to 3x plus c. So pause the video and try it for yourself and then play, and I'll show you the solution. Okay, so for part A here, we're going to have the coordinate -4, -13. Does it lie on the line with the equation y is equal to 2x minus 5? So the one way to find out is by substituting x and y into our formula. So our x value is -4 or -4, and our y value is -13, and we have -5 here. So 2 times -4 is -8, and then we have -5 here. Well, -8 minus 5 is -13, so this point does actually lie in the line. Okay, let's look at the second question. It says, given that C, find C given that we have a coordinate that lies on the equation y is equal to 3x plus c. So we're just going to substitute the values that we have, x and y, into the formula. So when y is equal to 2, we have 3 times 2 plus c. 3 times 2 is 6. 2 is equal to 6 plus c. If I minus 6 on both sides, I end up getting -4. Therefore, c is equal to -4. Okay, that means that the formula is going to be y is equal to 3x minus 4. That would be the formula for that equation. Okay, so question 6 talks about parallel perpendicular lines. It says line L has a gradient of -1/4 and line M has a gradient of 3/5. Find the gradient of any line which is parallel to L, parallel to M, perpendicular to L, and perpendicular to M. Okay, so pause the video and try it for yourself and then play, and I'll show you the solution. For part A, the question says that we want a line that is parallel to L. Remember, L has a gradient of -1/4, so we have an equation, something like y is equal to -1/4 x plus c. We just want to have the same gradient, okay? We want to have the same gradient. So find the gradient of any line which is parallel to L. If it's parallel, it means it's going to have exactly the same gradient. So therefore, a line that is parallel to L would have the gradient of -1/4. Okay, -1/4. Let's look at part B then. Part B says parallel to M. If we look at the line M has a gradient of 3/5. So if we're going to find a line that is parallel to that, it's also going to have the gradient of 3/5. Okay, so it's going to be 3/5 x plus c. This is going to be our gradient. Okay, 3/5. Part C then, part C says perpendicular to L. Remember that line that is perpendicular will have a gradient which is the negative reciprocal. So line L has a gradient of -1/4. So the negative reciprocal of this will equal to 4/1, okay, which in this case is just 4. Part D then, it says perpendicular to M. We know that M has a gradient of 3/5. We're going to find the negative reciprocal, which is basically going to be 5/3 and negative, okay. So that will be the gradient of a line which is perpendicular to M. Okay, question 7 says, write the following equations in general form. A is y is equal to 3x plus 7 and B is y is equal to -4/5x plus 2/5. So the general form would be ax plus by plus c is equal to 0. I want you to write these equations in that general form, okay? So pause the video and try for yourself. Okay, for part A then, we have the equation y is equal to 3x plus 7 and we want it in general form. So the first thing I'm going to do is I'm going to move my y across. So I'm going to minus y on both sides. That's going to give me 3x minus y plus 7 is equal to 0. You can just move the 7 on the other side and say 3x minus y is equal to -7, okay? And that will be your solution in general form. Either one is fine. For part B, we're going to do the same thing, a similar thing. Y is equal to -4/5x plus 2/5. Now I want my x to be positive, so I'm going to move it on the other side. Okay, so I will plus 4/5 x on both sides. Okay, so that will give me 4/5 x plus y is equal to 2/5. But I don't want it to be a fraction. I need to be an integer value, okay? But I need the coefficient of x to be an integer, a whole number. So what I'm going to do is I'm going to multiply everything by 5. Okay, multiply everything by 5. That's going to eliminate the 5 on the 4/5x, which gives me just 4x plus 5y, and here it will cross out the 5, so we'll end up getting equal to 2. So 4x plus 5y is equal to 2. Remember, you could do 4x plus 5y minus 2 is equal to 0 if you're going to do it in this general form, okay, equal to 0. Either one of these are perfectly fine. So question 8 then, consider a triangle with vertices P 2, 1, Q minus 4, minus 3, and R minus 2, 7. Part A, classify the triangle as scalene, isosceles, or equilateral. And then part B, determine whether PQR has a right angle, and if it does, state where it is. So pause the video, have a go, and then play, and I'll show you the solution. So what we'll do is we'll draw a graph and plot the points so we can see the shape of the triangle. So here we go. I'm going to say each square is 1 unit. So we can just quickly draw this down. We've got 2, 1. So 2, 1 is there. We've got -4, -3. So -4, -3. And then -2, 7, which is here. Okay, that's my y and that's my x, of course. And what I want to do is I just want to join these points up to see what type of triangle is formed here between these points. Okay, that's good enough. So is it equilateral, isosceles, or scales? We don't know until we work out the length of each side. So let's write these points down. Remember, we have... So I need to find the distance between these points to work out whether it's isosceles, equilateral, or scalene. Let me just zoom in here, and then you can see I've got a rise of 1, 2, 3, 4, 5, 6, and then you can see the run is 1, 2, 3, 4. So we have a run of 4. So we'll do 6 squared plus 4 squared, 36 plus 16. So that's going to be the square root of 52. We'll leave it as a square root of 52. That is this point here, okay? Let's go ahead and do the same thing for these points. Let's go ahead and just draw this triangle in roughly. Okay, so we can see that we've got a run of 1, 2, 3, 4, 5, 6. And then my rise is 1, 2, 3, 4. That's going to give me exactly the same as above. Again, I'm going to get the square root of 52. So I've got two sides that are the same. That's brilliant. Let's go work out the third size. So we get a run of 2, I can see that straight away. And then I've got a rise of 10. So I'm going to have 10 squared plus 2 squared, 100 plus 4, the root of 104. Right, so this clearly is not an equilateral triangle, and it's not a scalene triangle, it's an isosceles triangle. We have two equal sides, so we have an isosceles triangle. We can write here okay, that triangle isosceles. And then it says determine whether PQR has a right angle, and if it does, state where it is. So do we have a right angle? If we do have a right angle, it probably is going to be here. However, if that's true and this triangle does have a right angle, then Pythagoras should work here, okay? Now I've got the square root of 104, was it? 104, the square root of 52 and the square root of 52. So therefore a squared plus b squared should be equal to c squared. So let's just quickly check this out then. We should have the square root of 52 squared plus the square root of 52 squared is equal to the square root of 104 all squared. 52 plus 52 equals to 104. So yes, that is correct. We do end up having a right angle triangle. The point is at point P. So that was a quick review of coordinate geometry. And if you want to see more videos like this, then make sure you subscribe, and I'll see you in the next one.